Welcome to this new video about the normality. In the previous videos, we have seen the molarity, the expression for the molarity, and the different equations for the molarity, like for dilution and for neutralization. And we have also seen the number of the solved problems on the molarity. Okay, now we are going to learn about the normality. As we learned in the previous videos that the concentration of a solution can be expressed either in molarity or in terms of the normality. Okay, so we have completed the molarity and we have learned about the molarity. Now we will start about the learning about the normality in this video. Okay, so the normality is expressed by the letter capital N. It is the number of the gram equivalents of the solute present in 1 liter of the solution. Okay, it is expressed in this way. It is number of the gram equivalents of the solute, which is represented by the small n, and volume of the solution, which is represented by the V. Okay, so n is equal to small n by V, and V should always express it in terms of the liters. So n is equal to small n by V into 1000. When the 1000 is when we express it in terms of the ml, because 1 liter is equals to the 1000 ml. Now, in this expression, we are substituting this small n. That is small n, that is number of gram equivalents. As we learned in the previous slides that n is equal to W by GEW. Hence, we are substituting this small n in this expression. Now, the molarity is n is equal W by GEW into 1 by V when V is in liters. Or if it is in ml, we should multiply it with the 1000. So the overall reaction for the normality is N is equal to W by GW into 1000 by V, where V is in ml. The units of the normality are gram equivalents per liter. Okay, this is about the normality. Now we will see the different equations for the normality. Now we'll move to the next slide. The normality equations. The normality equations for dilution. The same equations we have seen for the molarity also. So the normality equation for dilution is equal to N1V1 is equal to N2V2. So here the N1 and V1 are the normality and the volume before dilution, and N2 and V2 are the normality and the volume after dilution. The dilution equations are like this. Suppose we are taking a solution of certain concentration, and suppose we add some water to that solution, it will become dilute and the concentration falls down. Okay, the relationship between the concentration before and after dilution is given in this way. Okay, so similarly, the normality expression for acid base neutralization is given as N1V1 is equal to N2V2. As we learned in the previous videos that the neutralization is the reaction between the acid and the base. Acid and base react together giving salt and water. So the expression for this is N1V1 is equal to N2V2, where N1 and V1 stands for the acid and N2 and V2 stands for the base. Okay, in vice versa, we can take the abbreviation in any manner as per our convenience. So N1 and V1 are normality and volume of acid, and N2 and V2 are normality and volume of the base. Okay, so till now we have seen what is normality and what is the expression for the normality and what are the equations of the normality. So now we will see some of the solved problems on the normality. So we will move to the next slide. Solved problems on the normality. So as we know that a normality expression is n is equal to W by GW into 1000 by V. So if you observe this equation, there are four factors. One is n, other one is W, other one is GW, and other one is V. That means all the problems that we are going to do is very simple problems, just a substitution. But provided out of four factors, they will give three factors, and we have to find out the fourth one. Okay, so let us start with the first type of the problem, where calculate the normality of the sodium carbonate solution containing 10.6 grams per liter. So for any problem, as we learned in the previous videos, that we should write the data first. So here data is, the weight is given, that is 10.6 grams. Volume is given, that is 1 liter. And we know that the equivalent weight of the sodium carbonate is molecular weight by 2, that is 106 by 2, which is equals to the 53. Okay. Now after writing the data, then we should substitute the data in the formula. The formula here is N is equal W by GW into 1000 by V. So here you just substitute the data and we'll get the answer as 0.2 N. Okay. So this is the first type of the problem based on the normality. Now we'll move to the second type of the problem. We'll move to the next slide. Problem 2. Calculate the weight of the sodium hydroxide present in 250 ml of 0.1 N solution. So here also first we should write the given data. The data that here given is volume is given, that is 250 ml. Normality is given, that is 0.1 N. So first given data, V is equal to 50 ml, normality is 0.1, and GW, here the sodium hydroxide molecular weight is 40 and number of OH minus ions are 1. So 40 by 1, which comes to the 40. Okay. That's how we should calculate the GW. In the previous videos, we have learned how to calculate the GW. For acid, it is molecular weight by basicity, that is number of replaceable H plus ions, and for bases it is molecular weight by number of replaceable OH minus ions. So in that manner we should calculate the gram equivalent weights. The equivalent weight expressed in grams is known as the gram equivalent weight. So after substituting this data in the formula, N is equal to W by GW into 1000 by V, then we will get the answer as 1 because it is weight. The units for this is the grams. Okay. So here also same thing. The three factors are given and we have find out the fourth one. Now we'll move to the next type of the problem. We'll move to the next slide. Problem 3. Calculate the weight of the sodium carbonate required to prepare 100 ml of 0.5 N solution given the solution. First, the data is that here volume is given, that is 100 ml. Normality is given, that is 0.5, and GW of the sodium carbonate is 53. Substitute the same in the formula. N is equal to W by GW into 1000 by V. So after substitution, we will get 2.65. Sorry, because it is weight, we'll express it again in terms of the grams. Units are grams. Okay, so now here also same thing. The three factors are given and we have find out the fourth one. Now we'll move to the another type of the problem. So we'll move to the next slide. Problem 4. Calculate the volume of the water to be added to 200 ml of 0.02 N NaOH solution to get 0.01 N NaOH solution. So for any problem, the first thing is we should read the problem very carefully, and second step is we should write the data very carefully, and once the data is written, then we will get the idea which formula has to be implemented over here. So here we should write the data very carefully. Here there are two volumes. One is 200. There are two normalities, two concentrations. First one is 0.02 and then another one is 0.01. That means first we have taken a solution whose concentration is 0.02 and to that we have added the water. This problem comes under the dilution and we have added the water so that the concentration has been decreased to the 0.01. Okay. So now given data, volume before dilution is 200 ml and normality is before 0.02 n, and normality after dilution is 0.01. Okay, so as we know that the formula for the dilution is N1V1 is equal to N2V2, and we should substitute this data carefully in the formula. So we get the final volume as the 400 ml. But here the final volume is not asked. Here what they ask is calculate the volume of the water to be added. How much water we are adding to the previous solution, that they have asked. So already previously we have 200 ml. So this 200 ml has become 400 ml. That means what? To this 200 ml of the solution, by adding 200 ml of water, it has become the final volume of 400. So the only water that is added is, we will get it by subtracting the final volume from the initial volume. So the final volume is 400 ml. From that, the initial volume 200 ml has to be subtracted, so that we will get how much amount of the water is added to make it dilute solution. Okay, so here this type of the problems with the dilution problems, they may ask in two ways. One way is, what is the final volume of the diluted solution? They may ask like that, or sometimes they'll ask, what is the amount of the water that is to be added for the to get that dilution. Okay, so we should read the problem carefully, and we should see carefully what is asked, whether it is the final volume or whether it is the amount of the water to be added. So if the amount of the water to be added is asked, then we should subtract the initial volume from the final volume. Okay? So this is one type of the problem. Now we'll move to the next time to see next video. Problem 5. 20 ml of the 0.2 H2SO4 reacts with 10 ml of the NaOH. Find the normality of the NaOH. So here, after reading the problem, we will come to an understanding that it is the reaction between the acid and the base, because there is one acid, that is H2SO4, and there is one base, that is NaOH. So this is the neutralization reaction. So we should write the data very carefully. So volume of the acid, 20 ml of the 0.2 H2SO4. That means volume is 20 ml and normality is 0.02, and then volume of the base is 10 ml. So we should, after writing the given data carefully, then we should substitute it in the formula N1V1 is equal to N2V2. So like that we will get the normality as 0.04. So this comes under the category of neutralization reaction. Okay? The previous problem comes under the category of the dilution. Okay? So now we'll move to the next topic. With this, we have completed all the solved problems on the normality. Okay, so now we'll move to the last topic of this chapter, solutions and colloids, that is colloids. So let's move to the next slide. Colloids. The definition of the colloid is like this. It is the heterogeneous system in which one substance is dispersed as large particles in another substance. Okay, so that is known as the colloid or the colloidal solution. That means here there will be two phases. One is dispersion phase and other one is dispersion medium. Okay, so for example, the best example for the colloid is milk, blood, smoke, dust, butter, clouds, etc. Okay. So if you take for example smoke. So what is a smoke? It is the combination of a gas and the solid. That means the solid particles are dispersed in the gaseous medium. Okay. So that's why we call it as the colloid. So it is the heterogeneous system in which one substance is dispersed as large particles in another substance. So here in the smoke, the carbon particles are dispersed in the gaseous medium. Okay, so it contains the colloid contains two mediums. The one is dispersed medium DP, and another one is dispersed phase DP and DM. Let us see what is DM. The substance in which another substance is present as colloidal particle is called the dispersion medium. So, in our example of the smoke, the dispersion medium is the air. And the dispersion phase, it is the substance which is dispersed as colloidal particle in dispersion medium. So, for example, in this our example of a smoke, the carbon particles are the dispersion phase. Okay. So, example here we have written very clearly. Example 1. In smoke, carbon particles are dispersion phase and gaseous medium is the dispersion medium. So, similarly, in the same manner, we'll see another example. Milk. Milk is the dispersion medium. In the milk, the dispersion medium is the water and dispersion phase is the liquid fat. So fat particles are dispersed in the water. Okay, so that's why it is the dispersion medium, that is water, in which the dispersion phase, that is liquid fat, is dispersed. Okay, so this is about the colloid. So colloids are these are all also the type of solutions. Okay, so the colloids, while defining the solution, we have defined the solution in this way. It is the homogeneous mixture of solute and solvent, whereas here the colloidal is the heterogeneous system of the, so in place of solid and solvent we are using the word dp and the dm. Okay, now this is about the colloid. Now we will see, we'll move to the next slide. Types of the colloids. Based on the interaction between the dm and the dp, the colloids are divided into two types. One is lyophilic and other one is lyophobic. So we know the meaning of the literal meaning of the philic. Philic means attraction. Phobic means repulsion. So let us take the first one, that is lyophilic. The colloid in which strong attraction exists between the DP and the DM are called the lyophilic. So here the DP and DM, there is a strong attraction between these two. Okay. So for example, starch, gum, gelatin, rubber, all these, there will be a strong attraction between the DP and the DM. That's why they are thick solutions. They are very thick solutions. Then properties of the lyophilic colloids. These are the solvent attracting colloids because there is a strong attraction between the solvent medium and the phase, and they are prepared by mixing the components. You can just, by mixing the components we'll get this type of the colloids. Okay, so we will continue the properties in the next slide. Third property, the precipitation of these colloids is easily converted to the colloid by mixing the DM. Thus, these colloids are reversible colloids. Okay. So, for example, if you take the gum and if you leave it for some time without closing the lid, what happens? It will become dry, it will become solid like. But when the water is added to it, again it will come back to its original texture. That's what it is written. So third point, the precipitation of these colloids is easily converted to colloid by mixing the DM. That is, the DM here is the water. So just by mixing the water, again it has come back to its original state. Thus these colloids are the reversible. Again, if it becomes dry, then by adding the water, it will come back to original. So likewise, we can do number of times. Easily we can get back its original state. That's why these are all the reversible colloids. So they are more stable because there is a strong attraction between the two mediums, and then they are generally formed by organic compounds of the high molecular weight. Okay, and then the viscosity is higher than the medium, and seventh one, the surface tension is less than the medium. Okay, so these are all the properties of the lyophilic. The lyophilic colloid is the colloid where there is a strong attraction between the dp and the dm, and then we have seen the properties of the lyophilic colloid. Now we'll move to the second type of the colloid, that is lyophobic. We'll move to the next slide. Lyophobic. So as we have discussed just now, the colloids in which weak attraction exists between the dp and the dm are called the lyophobic. So the attraction between the dp and dm is very weak here. Okay. Example: gold sol, platinum sol, ferric hydroxide sol, etc. So what is sol? Sol is the solids in liquid type colloids are called the sols. Okay. So here they are not the there is no strong attraction between the dp and the dm. Okay. So properties just like lyophilic, we'll see the properties of the lyophobic also. First property, they are solvent hating colloids. Just now we have seen that they are there is no strong attraction, that's why they are solvent hating, and they are prepared by special methods. Okay, whereas there that just by mixing we can prepare, but here they have to be prepared by a special method, and the precipitation of these colloids is not converted to colloid by mixing the dm. So in the previous type of the colloid, what we have seen, if for example, if we take the gum, if the gum becomes dry, just by adding the water, the gum will come back to its original state, that is semi-solid liquid, semi-liquid state. Whereas here that is easily uh, uh, converted from that to the by mixing the dm, but here it's not possible like that. The precipitation of these colloids is not converted to colloid by mixing the dm, thus these colloids are the irreversible colloids. Okay, whereas the lyophilic colloids are the reversible colloids, here it is the irreversible colloid. Okay, so now we'll continue the properties of the lyophobic colloids in the next slide. The fourth one, these are less stable. Lyophobic colloids are the less stable. Fifth one, they are generally formed by low molecular weight inorganic substances. Low molecular weight inorganic substances. And the viscosity is same as medium, and surface tension is also same as the medium. Okay, so this is about the colloid definition, and we have seen the types of the colloids, and then we have seen the properties of the colloids. Okay, now we will learn about the applications of the colloids in the industries. So now we'll move to the next slide. The industrial application of the colloids. First application, the purification of the drinking water. So impure water contains negatively charged clay particles. These are removed by adding the alum as coagulant agent. So in the water technology, we have learned that the impure water can be purified by adding some alum. So alum is nothing but the coagulant which separate out all the dust or all the solid mud particles. So here the impure water contains these mud particles or the clay particles. They are charged particles. So they can be removed by adding this alum as the coagulant. So second one, in food, they are the colloids are the milk, butter, cheese, ice cream, etc. These are all the colloids. And then medicine. The medicine, most of the medicines in use are the colloids because they are most effective in the colloidal form. Most effective means immediately they'll start reacting. Okay, if they are in the colloidal form, immediately they start reacting uh, in our body. For example, milk of magnesia is used for stomach disorder. That milk of magnesia, it's like it's available in the bottle, and if we keep it for some time, then what happens? All these particles will settle down, and we'll see the DM or dispersion medium at the top of the medicine. Okay, so that means it is a type of the colloid which is used for the stomach disorder. So because it is in the colloidal form, it will react very easily. It will show its start working very easily, immediately in our body. So similarly, antibiotics. The antibiotics like penicillin and streptomycin, they are used in the colloidal forms only. Okay, and then fourth application, in the smoke precipitation in the large industries where the release of the smoke is very high, then they'll use the apparatus called the Catral electrostatic precipitator, which works on the power. Through power, highly voltage electrolytes will use there. Okay, so here the smoke particles like clay particles, they are also charged particles. So the smoke particles are removed by the Catral electrostatic precipitator. Okay, so now we'll continue the application of the colloids in the next slide. Fifth one, tanning of the leather. In the process of tanning, positively charged impurities are removed by adding the tannins. Okay, and sixth one, extraction of rubber. The negatively charged rubber particles that are present in the latex are removed by adding the coagulants like acetic acid. So the rubber is obtained from the plant, and they will collect the latex, that is the milk white substance from the plant, and then the that milk like latex contains the rubber particles dispersed. It's a colloid. Okay, so those rubber particles are removed by adding the coagulants like acetic acid. If you add acetic acid, all the rubber particles will get separated from the medium. Okay. Now, seventh application, photography. Photographic films are prepared by coating the colloidal silver bromide on celluloid films. Okay. So next, last one, eighth one, the cleaning action of the soaps and the detergents. In the cleaning action of soaps and detergents, soap molecules form aggregated colloids. So as we know that when we apply the soap, then all the dirt particles or the mud particles which are will be separated out by the action of this soap. Okay, so the molecules form the aggregated colloids. Okay. So these are all the applications of the colloids. With this, we have completed the topic colloids also. Okay. So with this, we have completed this chapter. And if we summarize this chapter, it's where we have started with the solutions. Then we have seen what are the, we'll move to the first slide. Yeah. The revision is like this. First slide, it is about the information of mine. So my name is P. Indira Radilakshmi, designation Senior Lecturer in Chemistry, General Section Branch, and I'm working as a senior faculty in the GPW Badanpet. And this chapter is in the first semester of Engineering Chemistry, whose code is 104. The topic is solutions and colloids. Now, so we have started with the definitions. Definitions, what is the definition of solution, solute and solvent? And then we have moved to the classification of the solution. So classification of solution can be done based on two factors. Maybe one is based on its physical state and another one is based on the amount of the solute. So based on the physical state, they are divided into gaseous, liquid and solid. So in this slide, we have seen what are the gaseous solutions. Then next, we have seen next slide liquid solutions, and then we have seen the solid solutions. So next, we have seen what are how the solutions are classified based on the amount of the solute. So based on the amount of the solute, they are classified into saturated, unsaturated, and supersaturated. So saturated, unsaturated, and supersaturated. Now we'll move to the next slide. What is saturated? And then once we have defined the saturated, it is very easy to define the unsaturated and supersaturated. So this slide is about the saturated, and next slide is unsaturated, and next slide is supersaturated. Then after that, we have seen what is mole. Mole concept, defined it the mole, N is equal to W by GMW, the different ways of expressing the mole. And then after that, we have in the next slide, we have seen the different solved problems on the mole. Okay. So from here we have seen the solved numerical problems on the mole. We have seen some 4 to 5 types. So this is the first type of the problem on mole, second problem, then third problem, and then fourth problem, and then fifth problem. Then after that we have moved to the another topic, that is AMU, atomic mass unit. So this is used to before we define what is atomic weight and molecular weight. Okay. Then after that we have seen what is atomic weight, and we have seen what is molecular weight, and then we have seen what is equivalent weight. And the equivalent weight is defined separately for acids, bases, and salts. So this is the equivalent weight of the acid, and then we have seen equivalent weight of the base, and then we have seen equivalent weight of the solid. Okay. Now we'll move to the next slide, where we have learned about the concentration. As we have learned, the concentration of a solution can be expressed either in terms of molarity or in terms of the normality. So now we have started with the first one, that is the molarity M. So the molarity is the number of the moles of the solute present in 1 liter of the solution. And then we have seen the expression for the molarity. Then we have seen the molarity equations for dilute and also for the neutralization. This is the dilute solution and this is the neutralization solution. Now, after that, we have seen so many solved problems on the molarity. So, solved problems, say some 5 to 6 problems we have seen. This is the first problem, and then second problem, then third problem, fourth, fifth. Okay, 5 problems we have seen. And after that, we have seen what is normality, the another way of expressing the concentration, the expression for the normality. And then we have seen the normality equations for dilute solutions and also for neutralization solution. And then again, here we have seen some of the solved problems. Problem 1, and the next slide, problem 2, and the next slide, problem 3, and then problem 4 and problem 5. So we have seen 5 solved problems on normality. And then finally, we have learned about the colloids. What is the definition of the colloids? What are the different phases in the colloids? And what are the types of the colloids? So then we have moved to the types of the colloids, lyophilic and their properties. And next slide, continuation of the properties. And then next slide, lyophobic definition and again properties. And next slide, continuation of the lyophobic properties. And finally, we have seen the industrial application of the colloids. So where these colloids are used, and that is the continuation in the next slide also. Okay. So with this, we have completed the chapter Solutions and Colloids. Thanks for listening.